Hi, I'm Chet Haas, an engineer on the Android team at Google. I work on graphics and animations, and today I wanted to talk a little bit about that. Specifically, I want to talk about value animator and object animator and how you can get different kinds of movement on the screen. So let's take a look at a quick demo. I call this bouncer. I have my little electric sheep at the top of the screen, and I click on the screen, and the sheep moves down in a very boring fashion to the bottom of the screen. Not much of a bounce. So let's take a look at another variation, which I call bouncer 1. So we run bouncer 1, and now we're actually going back up to the top of the screen, which is a good start. It's actually continuing to move, which is kind of what bouncing is about. But it's got this weird sort of linear oscillation thing going on. So let's see if we can do a little better. We have this other variation, which I call bouncer 2. And I can click that, and all of a sudden we've got a bouncing motion. So we'll see how we create that with one line of code. And finally, we've got this other variation called bouncer 3, which is going to look remarkably similar to bouncer 2. We've got the same bouncing gravity motion going on there. The interesting part is in the code and how that one was created using a different kind of animator. So let's look at the code now. So we've got this bouncer file. Go up to the top of it. You've got this activity called bouncer. We have a custom view where we're going to be drawing this sheep as it moves around on the screen. And here we have a setup shape where we decode this resource. So this is the electric sheep thing that I spent hours and hours drawing because it's such complex art. We get the width and height of this thing to position it appropriately later so we can sort of center it in the screen. As we change the position properties of the sheep to put it in the center of the screen or to move it down and back up the screen during the animations, we call these setters, set shape X and set shape Y. And this one basically figures out the only reason there's any complex code in here at all is because we need to invalidate the correct area so that we erase where the sheep was and then draw the sheep in the correct area. Otherwise, we're going to leave litter artifacts all over the screen if we're not erasing correctly. Or if we just do an invalidate of the entire view, then we're basically going to be doing too much work because there's no reason to erase the entire view if all you did was move the sheep from here to here. So we get the union rectangle and we invalidate appropriately, and we do this for both of the setters here. On size change, this allows us to center the sheep appropriately when the size of the window changes, and on draw is where all of the magic happens for actually drawing the sheep on the screen. We simply draw the bitmap at the shape X and shape Y properties that were set before. For running the animation, we have the start animation method here that gets called when you click on the thing, and we create a value animator object. And this is one of the new classes that was created in the 3.0 release, part of an overall more robust timing and animation engine. Value animator is basically the timing, the meat of the entire animation package. It's the timing engine behind object animator, animator set, and view property animator, and we'll see all of these in future episodes. And all it is a timing mechanism, a timing and value calculation mechanism. Doesn't know about views, doesn't know about objects at all. All it knows how to do is to calculate values based on parameters that you give it for the start and the end values, as well as durations and other properties, which we'll see today. So we create this value animator by calling getValueAnimator. This comes down here and says valueAnimator.ofFloat, and this is going to calculate animation values between starting value of 0 and an ending value of 1. And then we add an update listener. And if you use value animator, which is a more manual way of doing an animation, then you probably want to have an update listener, and this will get called on every frame of the animation, and then you can do whatever you want to with the values. So every time we get a call, let me reposition this code a little bit so you can actually see it on the screen. On animation update, we get a reference to the animation object itself, and then we can get the animated fraction, so we can find out between value of 0 and 1 what is the current animation fraction. And we could also get the animated value at that time if we wanted. Here, we're just going between 0 and 1. It doesn't really matter. And we basically use that animation fraction between 0 and 1 to affect the height of the sheep. So we basically want to move the sheep from the top of the screen down to the bottom of the screen minus the height of the sheep. So we're going to take the 0 and 1 factors that we get during the animation itself and simply apply that directly as a proportion of the height at which the sheep is drawn. And That's all to Bouncer. So it gets a little bit more interesting once we start adding actual bouncing capabilities. All this one does is animate the thing down to the bottom of the screen in a very boring fashion. Bouncer 1 is a way to do that with a little bit of repetition. This is the one that oscillated down to the bottom of the screen and then back up. So here we get value animator, same exact thing going on, but we also set a repeat count of infinite, which means it's just going to repeat until you finally quit the application because it's not very interesting. And it's also going to set a repeat mode of reverse. So when it reaches the bottom, it's going to animate back up to 1. Internally, what that means is the value animator is going to run from 0 to 1 and then back to 0 and ad infinitum until you kill the application. Then we start the animation. Okay, that was the second animation. The third one was the one where it was actually bouncing. It was speeding up as it fell down, and then it slowed down as it went back up, sort of a gravity motion to it. So that logic is in the Bouncer 2 file, and it's exactly like the previous one we looked at, except for this one line of code where we set an interpolator. An interpolator you can think of as a way of reinterpreting time. And by reinterpreting time, we also reinterpret how the values are calculated, because those are based on the time value. So here we're saying use an accelerate interpolator, which means the longer you go, the faster you're going to get. But then, interestingly, when it reverses, it's going to use the interpolator in reverse. So it's going to speed up on the way down to 1, and then it's going to slow down back up to 0. And that's how we get the bouncing behavior as we go down and up the screen. And then finally, we can take a look at the Bouncer 3 file, which produced exactly the same visual result, but with a little less code. This gets into use of the new Object Animator class that also came out in 3.0. And this is a class that's specifically not just about animating values, but about animating the values on a target object and a set of target properties. In particular, we're going to have an Object Animator, which is created right here, that's going to animate integer values. It's going to use this target, which is the custom view, and we're going to animate the shape y property, which is just a string that we're passing in, which will then use reflection or JNI underneath to say, okay, well, given this string name, is there a setter of this type that I can associate with this, and then call that setter over time to animate. And in fact, it does find that because we have the set shape y setter that we saw earlier. And it's going to animate that property from a value of 0 to the max value. So you can compare this to what we saw before, where we created the value animator, and then we needed to use an update listener to actually use that value over time. Object Animator does that all for you. You point it at the target object to animate, the properties in that object to animate, and the values to use. Then you simply start the animation, and away it goes. It calculates the values, it sets it on the target object, and it's basically a set and forget thing. You create the animation, you run it, and you're done. So this was a little bit about the property animation system that started in 3.0. So if you're running on devices with 3.0, I would suggest you take a look at these classes, in addition to the View Property Animator class, which we'll see in a future episode. Thanks.